Most production outages don't come from bad code, they come from waiting. One slow service drags everything down. The usual suspects: no timeouts, aggressive retries, and missing circuit breakers. Let's unpack this trio properly. Welcome to Code with Clarity, the channel where we break down complex systems, production failures, and real world engineering problems into ideas that actually make sense. Imagine a payment service calling a risk engine. Normally, that call takes about 100 milliseconds. Then one day, the risk service slows down 5 seconds. If there's no timeout, the calling thread just waits. Now imagine hundreds of these requests coming in at the same time. Very quickly, your thread pool is exhausted. The system isn't down because of errors, it's down because everything is waiting. Timeouts are the first line of defense. A timeout is you saying, "I'll wait this long, and if you don't respond, I'm moving on." In a payment system, this might mean a risk check gets 500 milliseconds. A KYC provider gets 2 seconds. These values shouldn't be accidental. If you don't choose them consciously, production will choose them for you, usually at the worst possible time. Retries feel safe. Something fails once, so we try again. But when hundreds of services all retry a low dependency at the same time, that's not resilience. That's a self-inflicted DDoS attack. Retries should only happen when failures are likely transient. Timeouts, brief network issues, and temporary overloads. They should be limited, and they should never fire immediately one after another. Backoff means waiting before retrying. With exponential backoff, each retry waits longer than the last. For example, 100 milliseconds, then 200, then 400. Jitter adds randomness to that delay. Without jitter, systems retry in sync. With jitter, retries spread out. This small detail prevents massive traffic spikes and cascading failures. Circuit breakers step in when failures or timeouts become consistent. Think of them like a fuse. When the failure rate crosses a threshold, the circuit opens. While it's open, calls fail fast, threads stay free, the dependency gets room to recover. Picture a Friday evening traffic spike. A card network becomes slow. Without resilience, calls wait, retries pile up, threads get stuck. Within minutes, all instances are maxed out. Dashboards turn red. Slack is on fire. Now imagine the same situation with tight timeouts, limited retries with backoff, a circuit breaker that opens when failures spike. Instead of a total collapse, you get degraded behavior. Some transactions fail fast with clear errors. The system stays up, and you have time to react. Retries are only safe when operations are idempotent. If retrying a payment can double debit a user, production will expose that instantly. That's why resilience patterns and idempotency always go together. So next time production randomly fails, ask 3 questions. What's the timeout? How are we retrying? And do we have a circuit breaker? Most of the time, the bug is hiding in one of those answers. So here's our question for you. What's the worst production outage you've seen that turned out to be caused by waiting? Share it in the comments. This is Code with Clarity, where we just don't talk about code, we explain how it behaves in production. We'll see you in the next one.